Hi, everyone. My name is Xunjun Liao, and I'm from University of Florida. And I'm going to present my final course project of patterns recognition to you. And my project is to deploy ARIS classification models as a website application, which means we can use the files in our device to and upload the files in the website and get the prediction result from the server and the backend of another and running on another device. So it realize the models pub, to be used in public. And in this project, I I will in this video I will introduce to you how I finish the project step by step. The goal of the project is to deploy the models into production by combining the front end and the back end. Of course, in doing the project, I implement many tools such as the Flask, the React, the Docker. All of the tools are all of the tools are used from the back end to the front end. And the React is based on JavaScript, which is helped in a web page design. And it is very useful and easy for the website design because it divided the website into different components. If you want to modify one component, you just do that kind of job, not like HTML. If you want to modify just a small part, you need to refresh the whole pages and do doing the many useless work. And for Flask is used for construct the web application frameworks in Python. Of course, the backend are all based on Python. Of course, it is a machine learning model. Python will be more easier to do that. But based on Python, there are two kinds of the tools are mainstream. One is the Flask, and then another is a Django. I compare the pros and cons of both tools. For Flask, it's a very flexible and highly expandable. Like you can write the code to realize whatever you want. But for Django, it's heavy loaded. You have many constraints and you have the format to be followed in each file, so it's hard to do the DIY jobs. And for Flask, it's very suitable for small-scale web pages development, and not like Django. If you developed a small website pages in Django, you need a lot of prerequisite to be done before that, and then you do the website pages development. So it is a waste of time. And also Flask also allow people to use the third parties libraries, but I didn't use it in this project, so that's not that important. And also the Flask can allows you to write different code to realize different functions during one files. But for Django, you are not allowed to do that. If you change the one files, you need to change a lot of files because they dependent on each others, and you have lots of work to be done. And Docker is to use to build up the images. Images is for safety. If you want people to use your code, use your work, but you don't want to share the code with others, you can use Docker to set up the images and run as a container, so people will not read what's inside, but they can still uh, have the benefit of your code. And Docker Compose is like a manager to manage different images and containers. And to realize the project, I need I need to tell you the structure of how the project works. for the front end. Front end is a web page, and it's you upload the file. Client uploads the files on the website, and the website will post the TXT files to the port. At the back end, we'll get the information on the port by request function. And after filling the prediction and the calculations, and the backend, the model will send back and send the response to the port, and the website will fetch the information on the port. Of course, the website cannot send the message directly to the backend. All of the communication are based on the local host port. That's a kernel part of the communication. So this is the structure of how the project works. And I developed the front end first. To begin with, I installed and set up the dependencies like the React, the Entity for render, and different kinds of packages needed. And I set up the structure of the website. Of course, if I have a structure, I can do some logical works like how the button combined with the prompt window, and what will happen if I click this button. So I modify the functions of the web pages in the third step, and then after doing that, if you I can realize the communication part. After the functions, I will get the files you uploaded, so then the communication part works. If I test the front end works smoothly, I will containerize into images for for other use in the future. And then for the backend, the most important part is the Flask, which is the whole framework of the project. It defines where I should put the front end, where I should put the back end, and when the communication works. And then I just set up the communication functions to get the information and send back the information. And then I set up the models, which I will introduce later. And the fourth one is to put the model into the right place and into the framework. And after testing the whole structure works and the model works, the communication part works, the combination of the front and the back end works, I will containerize it into an image file with a doctrine. The same, this means two images, one for the front end or one for the back end, because it can only run one mission at a time for one container. So for the models, for the classification models, I use the deep neural networks without convolution, not CL, it's there. And with the learning rate after testing, the 0.05 is good parameters, and with a layer of 5. One input layer, one output layer, and 3 hidden layers. Of course, uh, I get I download the dataset from the UCI, the University of California, Irvine, and so it has 3 class of files. And I tried to avoid overfitting. I set the momentum equals to 0.99. If it's too small, maybe it's converged too fast and it maybe jump over the global optimum. That is not an ideal solution. And I set the iterations with 2000. And the optimizer I set is AdaGrad instead of SGD, because the AdaGrad is more like an adaptive step size when updating the weights, because it takes the second order momentum. When taking the second order momentum, it means it more seems like uh, for a node that, for example, a node that uh, updating frequently with every iterations. Maybe it need smaller steps, but for some nodes that just updating occasionally, it need more steps, a larger step size in each iterations. So that's how ADA graph works. And the active function I choose rarely. And here I will show you the result of the result